I don't wanna grow up, I'm a curious kid. The world has 100 questions I can play with. So I'll open my arms and eyes and wonder every day till the day I die. No one really knows why gravity exists.
I've been giving this series of healthy aging talks at my gym. And so what I do is I've reached out to Tucker and said, hey, I've got a new talk. Would your community like to hear it? And he graciously allows me to give my presentations here. So first, I've got nothing to sell. I'm not trying to convince you to buy anything or do anything. I'm just your friendly neighborhood epidemiologist. I do research in aging, and I feel it's our responsibility to educate everybody. So that's why I'm here. And I'm very excited about this topic. I've just come back from this huge international meeting of frailty and sarcopenia research. Sarcopenia is the loss of muscle as we age. And we're in this really exciting time where the biology has converged for us to understand better the role of muscle in health and aging. And I think it's time to share it with the world. So thanks for being here. And if you have questions along the way, please ask. Don't be shy. This is part of a larger healthy aging series. So I want to talk a little bit about aging first, age and aging, and then we'll get into the muscle specific things. So I want to distinguish between age and aging. So age is a number, and that's the number of years you've been around. So it's kind of like your odometer on your car. Aging is the process, how you get there. That's kind of like the gas pedal. And so, we can talk about the people who've lived the longest. For example, this person here, I show this in all my presentations, who's the longest known lived human. She lived 122 years. She was French and had a very exciting lifestyle, apparently. The man on the right, who's still alive, is the world's oldest marathon runner. He completed the London Marathon at 100 years old. And so when I kind of compare these things, I really think that most of us in the aging world who aren't trying to sell you something, really are on the right-hand side. We really want to add years, not just years to life, but life to years, making sure that we age well. And so just think about aging as a process that we all want to improve. And so we a lot of times we're thinking about aging, or it's portrayed this way in the popular media, like age is a bad thing and it increases risk of all these bad things like diabetes, cancer, Alzheimer's. And really what I want us to think about is aging as this process that we can own, and think about aging and being resilient and strong and active and taking control of your health, basically. So aging isn't something that happens to you. Aging is something that you can control, and I really do believe this. And I think today, hopefully you'll learn some practical things to keep yourself going and happy and healthy. And so one of the things I wanted to update you on is there's this whole field now that's emerged in the last couple of years around biological age and chronological age. And if there are researchers in the crowd, you know what I'm talking about. But the classic way of thinking about age and disease is on the left here. So as we get older, the prevalence of things like cancer, diabetes, cardiovascular disease increases as we get older. But we know that some people, look young for their age, and some people look old for their age, and may actually be younger or older for their chronological age. So thinking about, well, maybe I may be 50 years old, but I've got the 40-year-old biological age, we're shifting these things a little bit to the left. And so when you think about age, think about your whole body here, and all of your systems, like your blood and your heart and your livers and kidneys and brain, and all these things are aging at different rates. And they age at different rates for different reasons, but now there are more and more sophisticated ways to understand how your organs and your whole body are aging. And there's this whole field of biological age that has emerged and is emerging and is growing. You can go online and buy a test and you will get a number that tells you your biological age. We're not really sure what to do with that yet. But I'll tell you that insurance companies are interested in this, for sure. And I'm in healthcare. We're interested in it because we think it's a good way to determine who might in the future be qualifying for certain procedures where you might not be denied because of your chronologic age. Maybe we should be using your biological age to make decisions. So again, that's in the far future. And there are age predictors that are based on your DNA. There are age predictors that are based on biomarkers in your blood. And why is this important? Well, we think it's important for a number of reasons. And I apologize for all this text here, but this is kind of important. There's a recent presentation given at the American Association for Cancer Research. This is like one of the big cancer meetings in the world, where this research group looked in a very large database called the UK Biobank, and it's this publicly available free database of data. And what they did was they looked at people who were born before or at 1965, or people who, at 65 or older, so that includes my age group, compared them to people who were born in the 1950 to 1954. So basically people born in the early 50s versus people born after 1965, and said, okay, who's more likely to be aging faster? Is their biological age faster than their chronological age? And it turns out the people born in 1965 and later, my cohort, appear to be aging faster. They're at a higher risk of aging faster than the people in the early 50s. And this is interesting to me. And so what is biological aging? It's kind of this accumulation of your lifestyle, environmental exposures, and all these different things. And it turns out that those people born in 1965 and older later who are biologically older than their chronological age have significantly higher risk of early onset cancer. So like lung cancer, gastrointestinal cancer, like colorectal cancer, and uterine cancer. So if you're in that group of people who's aging faster than your chronological age from 1965 on, you're more likely, you're at a much increased higher risk of getting early onset cancer. So the idea here is that we think this may be an indicator of why we're seeing much more early onset cancer in the clinic today than in the past.
Is this globally or for UK citizens, or what
This is across the UK, so it includes all of the UK. The reason this is done in the UK is because they created this fantastic database called the UK Biobank, where they've taken almost 1 million people across the country, sequenced their genomes, made their medical records available for research, and generated this kind of biomarker data in order to understand this. So if this can be replicated in other places in the world, that would be fantastic. But just kind of giving you an update of what's happening in the field of aging is there's a lot of work being done on biological age, not just chronological age.
Are there hypotheses about why this discrepancy is showing up?
Yeah, there are hypotheses, none of them have been played out yet, but it seems the main hypotheses are around there are different exposures that people born after 1965 were exposed to in early childhood than maybe people born in the 50s. So different diets, different pollution maybe, we're not sure yet, but this again is maybe a marker of lifestyle and environmental exposures. But we're not sure yet. That would be many steps down. What is the cause? Okay, so the topic for today is muscle function aging, and I'm gonna put this talk together in 3 sections here. So we're gonna talk about muscle and strength and health outcomes. So give you the background of why this is important. Then I'm gonna tell you what's happening to your muscle as you age. And then I'm gonna tell you what the recommendations are for keeping muscle function, improving muscle health, because by then you will hopefully be convinced that you need to go out and be fit and strong. Part of being here too is to educate. And I want to make you good consumers of health information that is out there, because there's a lot of bad health information in the media and on the internet, And every day I've got like thousands of windows open on my computer for all the bad stuff that I see on the internet that drives me crazy. And the first thing you'll see is like, a study shows that this diet makes magic happen. Like a study shows, a study shows, a study shows. And Steve Cummings even talked about this. And so I'm going to talk a little bit about what we mean when we say correlation. The guy's not actually doing anything. He's riding along. And causality, these people are actually pushing the truck. Correlation is not a bad thing. A lot of what we do is correlative. It doesn't mean causation. And so these are differences that we can assess using different study designs. So correlational would be a large observational study, and I'm going to present data that comes from these types of studies. We can do these in large populations of people. We can follow people's outcomes for many, many, many decades if possible in many data types. So this is what that UK Biobank aging study would be. It'd be observational. You measure a bunch of stuff in people and see what is correlated. And the key is that we find associations between exposures, behaviors, and outcomes. This is not causation, but a lot of times in the popular media, this is represented as causation, and it's not causation. The only way to understand causation is through doing a clinical trial, meaning there's a placebo and people get treatment. Classically, it's a drug trial. You get a placebo or you get the drug. You can do that with exercise, you can do that with all sorts of things. These tend to be harder to do, smaller study sizes. You can't follow people for that long because you can't make them be on the same diet for many, many years, that sort of thing. So this is a way to understand causation, but they're smaller studies. And I'm going to tell you as we go along when I show you data, what the different study types are. But this is just to arm you when the next time you read an article, whether or not it's an association study or a causation study, it really depends on if it's a clinical trial with randomization or an observation. And also make sure it's in humans, because most stuff's represented as a mouse study, right? All right, so what happens as we age? So as we age, we lose muscle, 0.5% to 1% per year as we age. So after our peak in the 20s, I'm sorry, we do go downhill when it comes to muscle mass. It's not just muscle mass, and you'll learn more about that in a minute. But really, when you look across the body, we lose muscle mass at different rates depending on where you're looking in the body. So this is data from 47 studies. So I'm only going to show you the biggest, best data sets I can find out there. So I'm not going to pick and choose. I don't pick and choose data to tell a story. I find the best data and let that tell the story. So again, I'm just being honest with you. So they compared 25-year-olds to 75-year-olds, so basically 50 years of life. What happens to muscles? So you lose about 20% of your arm muscle mass over that 50 years, 24 to 30% of your trunk muscle mass. It really depends across your thighs, whether or not you're losing quads or hamstrings or adductors. And quads are important because that's really what you need to stand up, go up and down stairs and be mobile. And the lower legs don't lose as much. But just letting you know that muscle kind of degrades with age, depending on what part of the body you're talking about. So here's epidemiology lesson 2. When I say 16 studies of a lot of people show us something, this is what it actually looks like in a publication. And again, I'm showing this because I respect you and I think you're all smart and you can actually understand where the data come from. So what they're showing here is there's 16 studies that have been published elsewhere, and what this is called is a meta-analysis. So they've taken all 16 studies and taken the results and summarized them. So what we see here on the left is high muscle. What we see here is on the right is low muscle, and what this is showing is that people with low muscle have a higher risk of dying over the lifetime of this study. So that's what all these little boxes over here on the right mean. This is the effect size, and this little line here is the error bar. So very large studies have small error bars. Very tiny studies have very large error bars. But what happens a lot of times is when you read the paper or the internet or whatever it is, it says a study showed you something. You might be only seeing the result from this one study. So if you only look at this one study, you'd be like, oh my gosh, low muscle increases my risk of dying 10 times, 9.97 times. But really, if you look at the data in aggregate, it's actually much lower than that. And if I were somehow an enemy of muscle mass, I might pick this study to say, oh, actually muscle mass is bad for you. So just saying, like, you really have to understand when somebody is writing an article about a new study, it's a one-off. And it's not in the context of all the world's data. So just keep that in mind, is that there's more than just that single study telling you about muscle mass and mortality.
So I'm assuming that the people that you're looking at have started out, are somewhat the same in terms, like, I would bet that they're not all bodybuilders.
No.
Or maybe there's some, or maybe none of them are bodybuilders. So I'm assuming that there must be some similarity in terms of their lifestyle.
There's usually similarity in
because
age
maybe
and other things, yeah.
differences that skewed the results. I don't know, but it's sort of a question.
Yeah, so you're thinking just like an epidemiologist.
Yeah.
And that's why when we do these studies, this isn't my study, these are published by other people, what we do is we do our best to kind of control for these other factors that we call confounding factors. So that's all baked into this. I just can't do an hour of epidemiology, but just saying, in the future, I'm going to show you a couple more of these things. You'll understand when everything's on one side, all the studies agree. If it's on the other side, all the studies agree. So what does all this show? That muscle loss over time can really significantly increase mortality risk. So it's not just mortality, but it's actually different types of diseases. So we can see here that you get lots and lots of studies that show low muscle is greater than 1, so you actually get a much higher increased risk of various diseases like cardiovascular disease, respiratory disease, and cancer. So again, this is muscle mass having impacts on cancer, cardiovascular disease, and respiratory disease. So again, the impact goes beyond just muscle. It's going to other parts of the body. Is there a question in the back?
I just wanted to go back to this other 57% slide, because I missed it was like 57% higher mortality risk at what point, at what age?
It's just over the time of these. So different studies have different follow-up times. So it's just over different periods of time. And it's not just that muscle mass is increasing risk of mortality. It's actually really interesting that this is a correlation study, that muscle mass is related to what's called VO2 peak. This is probably the best measure of what we call fitness. And it's a measure of your cardiopulmonary output related to stress. So you go on a treadmill and then you measure your VO2 max. It's your body's ability to deal with that. So if you're going on a treadmill, are you huffing and puffing? Or are you really just dealing with the stress of working out? And muscle is a very strong predictor of that as well. And so it's not just muscle mass, it's muscle quality. And we're gonna have a few slides on what muscle quality means. So what is muscle density? So how dense is the muscle? How much muscle material is there within that muscle? So what we do is a thing called a CT scan of people's thighs. So these are thigh muscle scans right across your thigh. And what happens is if you look across low to high muscle densities, sorry if these are a little blurry, but the take-home message here is that thigh muscle density going from low to high is related to better grip strength, is related to lower mobility limitations, so ability to walk, get out of a chair, go up and down stairs, get the groceries, and is even reduces risk of mortality over time. So it's not just muscle mass, it's muscle density, that's a quality measure, and there's this phenomenon called muscle fat infiltration, and this happens as we age and become more sedentary over time. So a healthy young person's muscle looks like this. This is what happens as we age. You can see that fat starts to infiltrate the muscle. So it gives you less muscle to do the work that your body needs to do. And if you compare the impact of muscle volume to what the muscle fat infiltration is predicting, you can see that muscle volume is fairly well correlated with walking speed and leg strength in men and women. If you look at the amount of fat infiltration, that's a much better correlate to walking speed and leg strength than is muscle mass. So this is been known in the field, but we're now able to assess this more and understand what its impacts are on health and aging. So again, muscle fat infiltration is a much better correlate of strength and walking speed than is muscle mass. So just getting a muscle mass is not going to tell you about this. And I put walking speed up here because that's probably one of the best predictors of lifespan out there, is how fast you walk. So fast walker is good. So what about strength? And so strength is downstream of muscle. And so there are lots of studies looking at hand grip strength and knee extension strength. And that's when you sit in a chair and you flex your knee out like this. And you'll see here from this little graph here that having high hand grip strength reduces risk of mortality, as does knee extension strength, to the idea that high hand grip strength is associated with a lower risk of death more in women than it is in men. So again, strength is a really important part of survival and health, and especially the grip strength. The knee extension isn't quite as strong, but there aren't as many studies looking at this. So this could be a power issue, this could be a statistical issue. But why grip strength? We think grip strength is a good overall measure of strength, and it's easy to measure in large groups of people. And so again, it doesn't mean you're going to go out there and start getting the grippy thing or the tennis ball or whatever to start gripping it. Grip strength is a good measure of overall strength and health. And in fact, grip strength is a really good predictor of what we call mobility impairment, and that's the ability to walk at a certain speed. So basically, the higher your grip strength, the lower your grip strength, the higher your chances of becoming immobile over time. And so for instance, in men, having a high grip strength or a medium grip strength or a low grip strength increases your risk of developing a mobility impairment. This is walking under 8 meters per second. And in women, you've got lower cut points, but the idea is that your chances of becoming immobile over time are really associated very strongly with your grip strength. And in fact, this is a study published by my colleagues in what's called the Honolulu Heart Program, where they measure people's grip strength in their 40s and 50s, and then 25 years later determined what their ability was to do things like household work, walking, going up 10 steps, lifting 10 pounds, dressing, bathing, etc. And the people with the lowest grip strength in the dark bars are just much more likely to develop all these different mobility and physical impairments over time than people who had stronger impairment. And again, this is like 50 years before the outcome. So this is a very strong predictor of things to come. And what's nice is that grip strength is so easy to measure that there are multiple studies that were done in the UK to basically show what the grip strengths are across the different age spans in men and women. So for instance, grip strength peaks at about, late 20s, early 30s in men, similar in women. And these kind of normative data sets are nice because then they allow you to understand, not just where you are in the world, but it just gives you an idea of where your data sit related to other studies. And this is my last thing on grip strength, I promise, and then we'll get into other things. But this is a really interesting study, and this is another kind of measure of example of what we can do in epidemiology, where you look at what's called these modifiable risk factors, where you can look at different risk factors independent of each other. So then you determine the independent relationship between the measure and the outcome. In this case, it's mortality. These are data from a large number of individuals, 155 individuals, from 21 high, middle, and low income countries. So this is global. And what they did was looked at what we call the population attributable frequency. Again, how much of that measure contributes to mortality in that population. So we have things like low education, tobacco, grip strength, poor diet, hypertension, pollution. We can go on and on and on. What we see here is low grip strength is just as impactful on the risk of mortality as is tobacco and poor diet. This is globally. And it doesn't matter if it's cardiovascular mortality or non-cardiovascular mortality. This is a fundamental measure of health that we have to consider when we're thinking about, global health and our own health. And in fact, when you look at the low and middle income countries, it becomes even stronger. So it's not that this is like a first world country problem. This is like really a global problem. And I like this analysis because it just compares the impact of physical well-being and strength related to other things we can control. Okay, so I talked a little bit, I referred to a little bit muscle changes with aging. Now we're going to get into kind of the fun biology part. So I mentioned before that here's a muscle from a young man and a sedentary older person. You can see the the fat infiltration in the muscle here. What's interesting is that muscle and bone have a very strong interaction. They talk to each other. They talk to each other through chemicals called myokines and osteokines. These are things that the muscle and the bone release to talk to each other. And what's very interesting is that the muscle that builds up in the fat that builds up in muscle, and there's actually fat that builds up in our bones as we age, is very different from the fat that we see in the mirror, right? So the adipose tissue that we see subcutaneously or even viscerally that surround our organs, this is a different kind of fat that is much more toxic and is much more inflammatory. And this is why you don't want this fat in your muscle. Tucker.
These are cross-sectional views of the thigh.
Of the thigh, yeah.
Right? So the bones are actually different size, and there's much more fat not only in the muscle, but even surrounding the muscle, right?
So there's fat around the muscle, in the muscle, and then there's fat in the bone.
Whoa. And
So-
the 60-year-old man seemed to have slightly larger thigh overall?
Well, it may be, but there's a lot more fat in this
Yeah.
thigh.
Wow, thank you.
But again, this fat that's in here is very different. So again, it's much more toxic and inflammatory, and so that is further breaking down the muscle that's in here. And so, what's the best way that's known right now to reduce the muscle fat is through weight loss. So general weight loss will also reduce this muscle infiltration fat. Question? Yeah, it does. It's a very sort of toxic chemical. So it breaks down the muscle more. And I'll talk a little bit about that dynamic coming up as well.
You're saying that weight loss reduces the fat in the
Yeah.
muscle even without exercise?
Yes. But exercise will also help, but just in general, weight loss is probably good. As of now, nobody's done large-scale studies of weight loss on this, because this is hard to measure. Those CT scans in large numbers of people in a clinical trial over time, blah, 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 blah. But weight loss is one of the best ways to reduce that muscle fat infiltration.
So if somebody has like really crappy grip right now, or a lot of trouble standing up, sitting down, their thighs are weak, quadriceps are weak, obviously weight loss is important, but would it be just through typical walking or more, massive amounts of exercise, or?
We will finish up with that. Other things but that's the question, so you're already getting there, so thank you. So other things that happen in muscle, our muscles are packed with these things called mitochondria. They're ancient bacteria that actually are in all of our cells, and they produce the energy that we all need to survive and live and come to HopMonk. And that's what produces ATP. That's our energy. And so what happens in healthy muscle, we've got healthy mitochondria, they do all the good things for us. And unfortunately, as muscle degrades and gets fat in it, our mitochondria also degrade. They just start to kind of fall apart, and quality control really goes down the tubes as we age. And you can just kind of find, that as we age, things like mitochondrial dysfunction go up and muscle mass and strength go down. And so exercise is one way to keep your mitochondria healthy and going. Another thing that changes with muscle is our muscles are packed with capillaries, blood flow, sources of nutrients and oxygen. And so these are from a colleague of mine. These are these beautiful pictures that are cross sections of muscle. And you can see that each muscle fiber should be packed with all these capillaries providing oxygen and blood flow to every muscle cell. And over time, these things just start to degrade as well. So we're really we're understanding muscle quality really at a very fine level so that we can hopefully identify interventions in the future, in addition to exercise, that will help you maintain your muscle quality. So this gets to kind of the breakdown question that somebody back there asked. So what happens as we age? So our muscle, just like our bones, are constantly going through these phases of building and breakdown. So you don't have one set of muscle that you live with through your whole life. Your body is breaking it down and building it up, just like your bones are being broken down and built up over time. So in a balanced situation, you have what's called a gain in muscle, so percent change, gain in muscle, and then breakdown of muscle, gain in muscle, breakdown in muscle. And these often happen after a meal. So after you eat, you get what's called a fed gain in muscle. Then you lose muscle a little bit as you're fasted, and you go back and forth. And so in a balance, you don't lose muscle. What happens as we age or we just don't use our muscles, the breakdown outruns the buildup. So what happens is you start to break down muscle more than you build muscle. And again, this happens as we age. So, you can't really control that. This is what happens. And so even if you have a high protein diet, you're not going to protein your way out of this. And one of the best ways, again, is to reverse this process is through resistance training. And there are really good data to back this up, that if you add resistance training, you basically get your fed gains in muscle back to counteract the loss of muscle. So really, through resistance training, and we'll get to specific recommendations later, you can reverse this disuse process of more loss than gain to really up your gains, or at least maintain muscle mass. Yes?
In an earlier slide, you showed that education was one of the greater reasons for mortality. Can we start learning at a later age and increase our mortality? Will it increase our mortality?
Will it decrease your mortality?
Increase our mortality. Our
education?
Education.
Well, that should decrease your
It
mortality.
should decrease.
Yeah. So so learning is a really important process for maintaining cognitive health as you age. So we can always continue to learn. So learning is a really important process.
But it's not going to add to muscle mass.
Unless you learn about muscle and then you go to the gym. I think.
Okay.
But, yeah. And so so when I talked about what muscle is going through over that time with build up and breakdown and build up and breakdown, this kind of brings up this idea of circadian rhythms, which I'm going through a circadian rhythm issue now, having traveled so far. So whenever you travel a long way and you feel like really out of it, I'm not that out of it, but when you feel out of it, it's because your body's full of these different clocks. And it's really interesting at every cellular level. You've got these clocks which are keeping time. They're keeping time in your muscle. They're keeping time in your heart. They're keeping time in your liver. They're keeping time in your brain. And what is impacting these clocks? So you have external influences. So sunlight is the major driver of the clocks because it comes in through your eye, and then there's a whole brain process that is sort of coordinating these clocks. But also when you eat, when you exercise, you can really manage your circadian clocks through a lot of external behaviors, but these clocks also have their own internal molecular process. And so I talked about this a little bit in my last talk. And so really, these clocks in all the different organs really should be synchronized with each other so that everything's in balance. So when your heart should be at the right time, your muscle should be at the right time, your brain should be at the right time. And as we age, those timings start to fall apart. Or as you travel, that's why you fall apart. And that's why you feel crummy after you've traveled for long distances until everybody catches up. And so a lot of metabolic disease, may result from this. And so what happens is as our circadian rhythms get disrupted over time, we get a lot of desynchronization across our bodies. Hormonally, what happens is we have what's called cortisol and testosterone. We have more cortisol, which is a stress hormone, less testosterone, and this basically shifts us to what's called the catabolic environment. Catabolic environment is what breaks down the muscle. So as we age, we're breaking down muscle more, and then we are also reducing the amount that we synthesize. And so over time, what happens when we sleep is day, night, day. We upregulate melatonin at night. That's the sleep hormone. Growth hormone peaks at night. Growth hormone is critical for repairing damage that our bodies have accrued over the day. So having healthy sleep is really important for growth hormone. We also have cortisol and testosterone peaks. These are related to muscle breakdown and muscle building. So in order for our bodies to be in balance metabolically, we need healthy circadian rhythms, and we need to get sufficient sleep at night to let the body take care of business. So that's why short sleep is a really big problem, because a lot of metabolic processes need a full night's sleep in order to play out. And in fact, exercise is a very strong driver of our circadian rhythm. So let's say you're an early shifted person who wants to become later, or you're a later shifted person who needs to become earlier. Consistent exercise at a particular time will actually shift the circadian rhythm of your muscles. So this is an example of a specific circadian gene that's expressed in your muscle. After several weeks of early exercise, like in the morning, or late exercise in the afternoon, you can actually shift your muscles' gene expression patterns to earlier or later after several weeks. So this is a very pliable system, the circadian rhythms, that you don't need any medications for. You can really improve your circadian health through consistent timing of exercise. And last slide on biology. This is the work that my group does, and so people never know what I actually do. We study large populations of people. This latest study that we've done is we've taken muscle biopsies from close to 1,000 people, and we look at what's happening in the muscle. So we look at all the genes that are expressed, what genes are turned on, what genes are turned down, and what is a good predictor of outcomes. And so we show that genes that are related to oxidative stress or denervation, which I talked about, which is the earlier, and then also autophagy, the body's ability to eat the bad cells and get rid of them. And these are all related to mitochondrial function, muscle mass, muscle strength, walking speed, and what we call VO2 peak, which is health. So again, we are looking down at the molecular level in muscle and finding that this impacts all these different aspects of our health and well-being up to the full body. So what do we do about it? Right? Yes?
So you say gene expression?
Yeah.
Does that mean that it's different for all of us?
Well, so this isn't genes. You can control it. So this is actually, when I showed back here, this is a gene. And you can control when it's expressed basically when you exercise. So expression is different from your DNA that you get like a DNA test. That's fixed, that's what you inherit. These are the genes that are turned on when your muscle is exercising, or when you're sleeping, or when some other metabolic process happens. Because not all the genes in your genome are turned on all the time. Some are turned on sometimes, some are turned on other times, some are never turned on. They're turned on during development, or they're turned on later in life. So what this is saying is that genes that are related to these fundamental processes have impacts far beyond the muscle, all the way out to your cardiopulmonary health and your walking speed and other things. So what can we do? Like, what are the practical things we can do? And as we were talking earlier, you don't want to dread exercise. You don't want to dread going to the gym. You don't want to dread strength training. So you want to do something that you like, that works for you, and that you're willing to endure. And this is one of the questions I get a lot is, what are the best types of exercises for me? And well, it depends. It depends what your outcomes are. If your outcomes that you're worried about are to avoid major conditions as we age, mortality, cancer, diabetes, and other things. And again, there are like many studies showing this, that compared to doing nothing, if you do muscle strength only, aerobic only, or both, hands down, doing both is best for you. So mix it up. So do a little aerobic, do a little strength, do them both. Not that either one individually is bad for you, it's just that you get the maximum benefit from doing both. And so you didn't know, there are actually resistance training guidelines that are out there that are publicly available by the various health agencies that make these guidelines. We all know there are cardiovascular ones, there are also muscle ones. And so this is the percent of people in our population survey data that meet the resistance training guideline of at least 2 times per week. This is only 2 times per week. This is, we're not expecting everybody to become total gym rats here. Just 2 times a week. And, it's all under 50% of people. It's higher for people 18 to 24, but at 65 plus, fewer than 20% of people meet this. This is just 2 times a week. And so what can we do to make it, because hopefully you're convinced that being strong is important for lifespan and health. And so what I find very interesting is that the American Heart Association, so usually you attribute heart health to aerobic training, they actually have a specific set of guidelines around strength training for improving cardiovascular health. And I'm impressed with myself. I made a QR code. And I'll put this at the last slide too. If you go to that QR code, it will pull up this publication that everybody can read. And so this is a set of guidelines that the American Heart Association has put together for strength training for people of different abilities. And so the takeaway message from them is that strength training is for everyone. Doesn't matter what age you are, if you're male, female, or whatever. If you have chronic conditions, and there are many ways to perform resistance training. And the sessions can be as brief as 15 to 20 minutes, doing 8 to 10 different exercise groups. So there are lots of ways to get strength training. And if something doesn't work for you, find another way. And you don't have to go to the gym necessarily. If you're at a gym, then have somebody there help you. But really what happens is by adding this strength training to your life, you're reducing traditional risk factors for cardiovascular disease, like lowering your blood pressure, lowering your glucose levels, lowering your lipid levels, changing your body composition. And these things are impacting the things you don't necessarily see, like arterial stiffness and inflammation. This will improve your sleep, and this will decrease your cardiovascular risk. So again, this goes beyond just the aerobic training for heart health. Strength training is also really important, and it's not overly burdensome. 2 to 3 times a week, 15 to 20 minutes per day. And in fact, they get into specific guidelines around people who might kind of have what they call high-risk patients, people maybe who are new to exercise, versus the general population, to those looking to really optimize strength. And what all this is really telling you here is, based on your strength, should you be doing lighter weight at more repetitions, or more weight at fewer repetitions, and it really depends on what your goals are. But this publication really highlights kind of the types of exercise modalities you can do to improve your cardiovascular and, frankly, overall health. All right, so one of the other interesting studies that I really like, that I was surprised that people had actually done this, this is from 21 studies. They asked the question, should you be doing strength and aerobic on the same day? I go to the gym, I go on the treadmill, and I do strength training, or should you separate the days? And it depends on what your goals are. So if your goals are to build muscle, strength, power, if you compare strength training to endurance training by itself or doing both, strength training kind of wins every time. So if you really want to focus on muscle strength and power, then you separate the days. Aerobic one day, strength the other day. But if you really want to focus on like overall fitness, what we consider cardiovascular fitness, you really need to either be doing concurrent exercise. It's better to do concurrent exercise, basically. Do them at the same time, or do just endurance exercise, because the strength training is really not improving that much. That's what this is showing us. So again, for cardiopulmonary fitness, you should do both, or endurance. And finally, they all will contribute to fat loss. So again, this is an interesting question that I see a lot of people when I go to my gym are kind of doing both, right? Which is a good fit. That's a really good way to do your exercise, is strength and cardio on the same time. But if you really want to bulk up or get strong or whatever, you might need to do it in separate days. So coming back to circadian rhythms, with another sort of interesting observation that's out there is, we all have preferences in our day, right? Some of us are morning people, some of us are evening people, some of us may be afternoon people. Well, it turns out that in humans, most people have their peak physical performance between basically about 1,600 and 1,800 hours, right? So again, like right around 4 to 6 o'clock. And it may not be for you, but in general, that's when humans have their peak physical performance. But what this study showed here, and this is a series of data from highly fit women who played lacrosse in college, showed that over time, physical peak performance was again right around this time interval, like 4 to 8 p.m. The women who identified as early people actually had peak performances which were earlier in the day. People who were midday peak self-identified mid-performers performed well midday, and the late folks performed better later at night. So there is this kind of preference for, like, if I'm a late night person versus an early morning person, that might show up in my physical performance. And look, if you're gonna exercise whenever is convenient. So this isn't telling you like, oh, you gotta quit your job because you have to exercise at 1 p.m. That's not what this is saying. It's just more of an interesting phenomenon that, our circadian rhythm is so strong that that actually drives our physical performance. What is important though, if you want to get the best performance out of your exercise, is to be consistent every day. Because what happens is your body kind of sets up this anticipatory process, just like when you eat meals at a certain time of day, your body prepares. And so it upregulates the right hormones to say, oh, it's about time to exercise, I better get ready for that so I can maximize the benefit of my exercise. So training over multiple days at a specific time will really give you your best performance at that time. And so if you exercise at the same time every day, your internal molecular clock in your muscles start to become trained, and that will improve your circadian physiology and health. And finally, it's not just what you do when you're exercising, and exercise doesn't have to be the gym, right? I give these talks at my gym, but it's also getting out and walking and running and kayaking and rock climbing or whatever you do. That's all exercise. That's what you do after exercise. So recovery is critically important, because it doesn't help to go and basically become too sore or injure yourself so you can't exercise for a week. So that's not the goal here. But what happens when we recover? And there's a difference between when we're young and as we age. So as we age, the cells that become muscle cells, these are like the muscle stem cells, become active and grow as we recover. But as we age, we have fewer of those cells, so we don't grow as much. When we're younger, we're able to clear out the kind of the bad cells, but that clearance of kind of the bad cells in our muscles becomes attenuated as we age. It actually leads to stiffness as we age. Our mitochondria go from highly energetic and ability to repair to becoming more reactive, oxygen species generating, and less able to repair. Inflammation increases. We're not able to deal with that as well when we age, and resolving inflammation becomes a problem. So we just have to be aware of, as we age, our ability to recover from exercise is just not quite as good as it was when we were young. So we have to tailor our exercise to this reality so that you don't, again, overdo it on your first day so you can't exercise for a week. You really have to respect your body, respect your age, and own your aging, so that when you exercise, these are things to really be considerate of. And I'll finish up with sleep, because sleep will be the next topic I talk about probably in the fall. Sleep is really important to your recovery. And this is a nice schematic from a series of studies that was done. So what happens when you sleep normally and have normal healthy sleep? There's really no change in muscle synthesis, meaning your breakdown and building up of muscle are in balance. That's good. You want to maintain that balance. In studies where they restricted people's sleep on purpose, so people signed up for these studies, so either depriving you of sleep for 24 hours or giving you short amounts of sleep for 5 nights in a row, what happens is basically that balance of buildup and breakdown shifts to breakdown. So your muscle is no longer keeping up with the breakdown because of this lack of sleep. And so finally, what's interesting, in the people who went through 5 nights of sleep deprivation, when they were also forced to do high intensity interval training, so if people go to the gym, it's HIITs, the kind of the happening new thing, that actually recovered the muscle buildup, so it recovered that balance. So basically, normal sleep, you're in balance. Reduced bad sleep, you become out of balance. Reduced bad sleep by adding in exercise retrieves that balance. So again, this is how powerful exercise is. Nobody here is recommending this. Okay, don't go home and don't sleep and then go and hit hard at the gym. Try for this. Try for healthy sleep and do your exercise. So I just wanted to kind of wrap up here to say we started with some age and aging, comparing biological and chronological age. Keep an eye on the field of biological aging. It's rapidly moving. It's kind of exciting. It's the Wild West right now. Maybe this is important for identifying early onset conditions. So we learned that muscle mass, muscle quality, and strength are critical for multiple aspects of healthy aging. And muscle strength and these various things are strongly predictive of future function and independence. Muscle changes with aging, so we know that muscle mass and quality decline with age, and resistance training prevents these declines and promotes growth and strength. And finally, the recommendations for improving muscle function. Resistance training is recommended for everyone, and recovery is very important. And so I'll kind of stop there and keep my fancy QR code up here if you want to access that. And if any of the information that I presented today is of interest to you and you want to learn more about it, these are all based on published studies that are publicly available. But if you email me, I'd be happy to send you those publications so you can read them for yourself and learn from the science. Because again, most of them are publicly available. And if not, I have them and then I'll send them to you because I have access to them. So this is my email. I think a lot of you emailed me last time, and I think I answered all your questions. Hopefully when you emailed me last time. Just please don't abuse it. Thank you. And so that's it. I hope this, motivates you to go out there and be strong and healthy. So, thank you.
Way back in the Middle Ages, they used to tell you that you shouldn't exercise late at night because it wakes you up.
I mean, that could be true, or it could work for you. Like, depending on what your kind of rhythms are and what your pattern is. So the slide I showed of the people who were kind of self-identified late night people, they peaked much later at night. So, but they were probably have a shifted rhythm to where they sleep later in the day and kind of stay up late. So they would be more like an owl versus a lark. So circadian wise, there are owls people who do better at night than during the morning, and larks are people who do better in the morning than at night. And that's just an inherent trait for some people, and if that's what works for you, you shouldn't fight it. The problem is when you have to live in a 9-to-5 world, it becomes a problem.
So can you shift your circadian rhythm by getting up and exercising, and will that help that?
Absolutely. That was one of the things I showed before about if you need to shift your circadian rhythm, and a lot of times our rhythms shift one way or the other as we age, and if it's becoming problematic, there's really no medication for it. You don't need sleep medication. I really try to avoid sleep medication whenever possible, please. But you can use those keys of exercise, timing of diet, timing of light, to shift your rhythm one way or the other. That is key. And in some countries where you get long nights and then long days, these light boxes are used to help you and train your circadian rhythm, especially in the mornings.
I'm thinking of that one slide where you showed the risk of death was really high for tobacco and bad diet, very high bars.
Yeah.
And then off to the right, a much lower risk of death. And one of those bars said low physical activity. Now, how does that consistent with all of this? Low physical activity is a lower risk of death.
Right. It depends on how they measure physical activity.
Yeah,
So
exactly. What do they mean by the low
right.
physical
That's going to be more sort of, I think, a question-based activity. So they're not measuring people's activity with like a wrist actor graph or something like that. So that's going to be exactly like a survey type question. The nice thing about grip strength is it's really easy to measure.
Yeah.
There's a dynamometer that has a dial on it. They're very standardized across the world. So those are good data. They're not they're not subjective.
Yeah, so
you can't lie about this.
Yeah. Right. I just had another question though. All of this is for skeletal muscle.
Good point.
Now,
yes.
What about the muscles we don't see, those that are in the digestive and the vascular system, particularly blood vessels, whatever, that have a fair amount of importance? The smooth muscle types. Do smooth muscle types subject to the same kind of degradative process that skeletal muscle is? Or are they immune?
I believe that they are, but I want to acknowledge your point is a really good one, and also the cardiac muscle is different too.
Yeah.
So this is all skeletal muscle based, so it's not smooth muscle like your intestine or your cardiac muscle. And the interesting thing about cardiac muscle is it doesn't turn over, right? It's what we call post-mitotic. So it's kind of what you're born with is what you live with for most of your life. So that's subject to all sorts of build up of bad materials over time.
Well, I realize though that trying to measure aspects of smooth muscle is probably very hard to measure it. How do some invasive technique?
Yeah,
it's not going to work.
Without hurting somebody. Yeah.
But I was just curious whether that is relatively immune to this degradative process.
Yeah, that's a good point. And if you email me, I'll look into it.
Yeah.
Just to be sure. I don't know, so I don't want to make up an answer.
Thanks.
I had a comment and a question. Seems to me that when that people that maybe don't have a tendency to exercise, some people end up getting dogs, very active dogs, and that force them to get out there and walk. I've met people while I'm walking who I like looking at dogs. People walking their dogs. I love seeing dogs, so inevitably I'll get into a conversation, and I can't tell you how many people mentioned, oh gosh, I've been walking the dog, I lost 20 pounds or something like that. So it seems that that's something that can be helpful. Not everybody can get a dog or wants a dog, but that seems to be sometimes helpful.
Indeed, whatever it takes to get out and walk and move around.
A friend that they can walk with. But I'm wondering about, I don't know if you look at this, but I'm wondering about osteoporosis. If you've also looked at osteoporosis in some of your studies in terms of impact, I don't know. I just thought I would, because you're talking a little bit about bone.
Mhm.
When you talk about aging, that starts to become a factor also.
Oh, no, indeed. Were you here for the other person who spoke? His name was Steve Cummings. He talked about pills and drugs for aging and things like that. He's probably the world's leading expert in osteoporosis. So he was standing up here. So he would agree with you. And bone goes through this really similar, interesting process where it's constantly turning over. So you have these different cells called osteoclasts and osteoblasts, and one is chewing the bone down and one is building it up. And again, that process also changes as we age. The bone also becomes infiltrated with fat like the muscle, and they are actually talking to each other. So everything that I've said here today is going to have positive aspects on bone health.
A correlation too in some of the exercise also?
Right.
I know it's different too.
It is, but it's not going to hurt. It's going to be, you're going to have a positive impact on your bone as well.
I've read some articles where they talk about exercising for fat reduction as a positive effect by exercising on an empty stomach, like from a fasting state in the morning. What do you think?
Yeah, so that's a really interesting question. So I've, in the past, I would have said definitely, because what you're doing is, when you're fasted, you're kind of going right to like the fat for energy and not using kind of other stores that are in there. But I don't know if the data have completely supported that. So I think that one, you should do what works for you. So if you feel fine fasted, great. And if you don't feel fine, then have a meal and then go exercise. But I don't know, I'd love to hear more. I should talk to my colleagues at the Buck Institute to see what they're, because they're doing a lot more human studies as well. But again, I think in the past, I would have said, yes, fasted, that's the best way of doing it. And I think that more recent data are kind of, it's not clear that that's the best. So I would really recommend you should do what works best for your lifestyle and gets you out there exercising. Sorry.
Your recommendation to do resistance training 2 to 3 times a week, is that based on data about how long it takes to build up and recover?
It's based on that, and it's also based on a slide I skipped because I didn't want to run out of overdue time. So basically, there was like a series of studies that I showed here that looked at many modalities. So exercising fewer times to multiple times per week, and also different types of exercise, lower weights at higher repetitions, higher weights at lower repetitions, to find that kind of sweet spot for maximizing, in this case, muscle mass. And all the recommendations coming from these studies, so it's 25 studies, showed that for strength and muscle mass, 2 to 3 sessions a week. We think this is a minimum and should be easily achievable for most people. Sets per exercise. So you can see all these things here, and I can go into each one if you want. But the idea is those recommendations that come from that American Heart Association and what you just asked, come from lots of studies trying to look at all the different modalities, and they've all kind of settled on this being the maximum benefit, especially for somebody who's just getting started. You know, if you want to start really building muscle and building strength, you're obviously going to need to up that to more times per week and heavier weights and things like that.
But the body does require time to recover and rebuild.
Correct.
So you can't do too many times per week because you're not allowing.
Or you can work yourself into that too, if you wanted to do more times a week. Here, and then back there.
Address that. I remember when Bruce Lee gave us his training schedule. He said, one day I do legs, another day I do arms. You know, basically, give some time to recovery. Otherwise, you keep overstretching and then a downward path.
We'll go here, there, then there. Sorry, so first one here.
As we get older, do we need more rest time between workouts?
That, I mean, that's what the sort of last slide I finished, one of the last slides I finished with is like, respect your body's need to recover. And definitely as we get older, our bodies just need more time to recover. So yeah, you might need that extra day, or maybe you need a light day after kind of a hard workout day. So just respect it. And if you're sore or things aren't feeling well, then don't do it. Or try something and go on a walk. You know, do something different. You know, when I see people who are in their 20s in the gym and they're just like going really hard, and it's just hard to keep that up, and it also hurts your joints and things. So yeah, give your body a chance to recover. The second one.
I don't know if I'm second or third.
You're second.
Okay, so older people, I keep hearing older people, if they don't exercise, you know, I mean, a minimum of 3 times a week, but they should do something almost every day. But if they're not doing something, that they really atrophy
Yes.
more quickly. How long is it gonna take to get it going again?
Well, you know, I showed this in my other talk and I didn't show it here, but resistance training for a really fun clinical trial that was done in 90-year-olds doing resistance training showed impact in 6 weeks. So improved walking speed, improved overall strength without much change in muscle mass. So it changed the way the muscle mechanics work. So it's probably neuromuscular, it's probably muscle quality and other things, but you can definitely see, if you're consistent, changes in like 6 weeks. Yeah. Yeah, well, biological age is a.
Greg, could you repeat the question?
Oh, so there, I think if I can, yeah, sorry. If I understand the question is, what is the impact of, you know, in addition to aging, like lifestyle, and other external factors related to muscle quality and breakdown? Is that kind of fair?
Well, these are mostly correlational studies.
Absolutely, they're correlational studies.
So is it, like, it's hard to say that it's due to aging or if it's due to us observing a population that has a lifetime of potentially bad habits under their belts that we're seeing. So, like, is it possible, or have there been studies done that are correcting for that by looking at something like biological age or comparing populations of people that have been sedentary their whole life or have been continually active and maybe have that higher grip strength even if they're in their 60s, 70s, 80s or beyond?
Right, so how do we account for differences in studies and populations that are being studied? Some might be super healthy, some might not be very healthy. And so a lot of it will come down to study design. And so there are studies where you might say, okay, in a diabetic population, can we, you know, what is the role of exercise? So those kinds of studies have, you know, have been done, a lot have been done. Or in our case, when I showed you the study of our muscle biopsies and kind of more global health, those tend to be in people who are in their 60s and 70s, who are generally healthy, so their inclusion criteria, like they have to be able to walk half a mile and be free of certain conditions. But for the most part, we are able to account for, at least statistically, certain comorbidities or existence of disease, so that we kind of, what we say, take care of it statistically in many cases. So we can then, at the end of the day, be comparing people who have multiple conditions to those who have multiple conditions versus people who have no underlying conditions versus those who have no underlying conditions, to try and then at least take away the impact of underlying disease or other behaviors that might be impacting the outcome. So we try and use statistical modeling or study design to take care of that. Because it would, you're right, I mean, it wouldn't do any good to compare, a person from a very healthy population to somebody who's got, many diseases and say, oh, well, muscle changes with aging. Like, we really do our best to control for all of what we call those confounding factors. And that's why our studies are more than just one predictor and one outcome. There's a lot of complicated modeling that goes into that. So I don't know if that helps, but we do our best to take care of it. Like, we really do care about these kinds of questions and think about it in a similar way. Did that help at all? Sort of, we can talk about it more later if you want. I saw it. Did you have a hand up or no?
Oh, I was just gonna make the comment that if you wanna go to a nursing home, get your quads. Your quad strength is what will save you from a skilled nursing facility.
Yeah, so quad strength will help you from, going to a living facility. Yes, it's interesting. One of the things that, I've heard certain clinicians do when they try to assess people in their clinics who are older is when the people come in, they put them in a chair to have their blood pressure taken or whatever, see if they need to use their arms to get out of the chair. Because that's that's a very big hallmark, not being able to get out of a seat using just your legs. So that's quad strength right there. So yes, that's very important. So work on your quad strength. Stand up without your arms. That's very important for you. Here and then there.
In your last talk here, you suggested, you said that you were using an eye shade. Does that change your morning to evening cycles?
It doesn't change that. It just helps me sleep better. And because it's like the room I live in there's a lot of ambient light coming from outside. I don't have blackout curtains or anything, so it just helps me sleep better.
Okay.
So for me, that works. But it is, it is kind of shocking when you take it off and it's light out. So that's not ideal either. Really, you should kind of ramp up the light and turn down the light. But I don't have perfect darkness at home, so that's why it works for me.
Thank you.
What's the percent 1 RM mean?
So 1 RM, percent 1 RM. So that means whatever your maximum is. So let's say your maximum is 100 pounds. Doing something 100 pounds. You should be doing, if you want to build strength, maximum strength, you should be lifting anywhere from 70 to 79 pounds 7 to 9 times. So it's telling you what your percent of your maximum is. If you want to build muscle mass, it's saying to actually go lighter on the weight and do those repetitions. So 1 RM is your sort of single lift maximum.
So if you're building muscle mass, aren't you building strength?
Not necessarily. So this is just like the example I brought up before where they took 90-year-olds and gave them a strength training regime. This is a clinical trial. They found that performance was dramatically improved without an improvement in muscle mass. Remember, it's not just mass, it's quality, is what we talked about before. So if you have more muscle fibers in that area, that's good for you. If you're getting rid of the muscle fat, that's good for you. If you're recruiting new nerves in there, that's good for you. So it's like you're changing the quality of the muscle, not just the size of the muscle.
How much were the 90-year-olds lifting?
That's a good question. I don't know. I can share the study with you, but yeah, I'm sure it wasn't a whole lot, but still, even, just the message from that study for me was like, it's never too late. It's never too late. And, a lot of this is focused on exercise that are gym related, and, because these are easy things to control in a study. It's easy to set up a study where some people do strength training, some people do aerobic training, some people don't do any training but get education, and you can monitor that. But what you do throughout the day is really important. So housekeeping is a type of exercise. Gardening is a type of exercise. All those things, take the stairs, that's a type of exercise. All those things are really important. So just saying, I went to the gym for 45 minutes or an hour, and now I can go home and sit around all day, that doesn't get it done either. So it's this other form of activity is really important as well to think about.
Another thing you can do, it's called run session, where you wear a weighted backpack on your back and you walk with that to increase muscle strength.
Wearing a weighted backpack to increase muscle strength when you walk. Sounds fun. I'm sure that works. I know that is an exercise thing. When people walk long distances doing that, sounds great. Tucker, maybe that's the magic bullet for you right there.
I'm gonna strap some helium balloons to my
Yeah.